Yes? No, 78 is not on the quiz.
Is it the mole?
This is the mole book. Mole book, page 78. What did I do with my pen? No. Where did it go? Oh, there it is. Okay. Having a panic attack. Okay, so we are going to be finding the molar mass of an unknown substance. Now, you know how to find molar mass if we know the formula, yes? Yes? Yes. But we can also find the molar mass of an unknown substance if we are given the right information, which sometimes we'll find in a lab, but we'll just be looking at it being given to you in a question, okay? So we have, now what is the unit of molar mass? Tell your partner. The unit is grams per mole, yes? And that means if you know the grams and if you know the moles, what could you do? You could find the molar mass, yes? And this is another one if you've got your yellow sheet kicking around. Do you remember? Molarity is a division. Density is a division. If you're finding molar mass of an unknown substance, that is also a division. Now, molar mass does not really have an abbreviation, okay? If you want to, you could abbreviate it as molar mass. Make sure you put the two little dots in there though, okay? I sometimes will abbreviate it as like a fancy capital M, but it has to be fancy, yes? And if you're not happy with fancy, then just don't do it. Just either write molar mass or write MM, yes? Molar mass. So if you're finding molar mass, all you do is you take your grams, you put it over your moles, and Bob's your uncle. Yes? Do you guys know that expression? Bob's your uncle. It's a British expression. It means, and there you go. Okay, so, and there you go. And Bob's your uncle. So let's go back to here. 5.4 C. There we go. Here's our formula. Molar mass equals mass over moles. So here we have a calculation. Super difficult. Let's find the molar mass of a compound if 0.472 moles has a mass of 178 grams. Straightforward enough for you? You take your 178 grams and you put it over your 0.472 moles. You do the division. Wake up, Brian. You do the division and you get 3.77 grams per mole. Okay? We can make it a little bit more complicated and we can say, instead of giving you moles, what if we gave you molecules and grams? Would you be able to find the molar mass? Yes. Now there's two ways to show it. Either way is fine. Okay, you can start by finding the moles by doing the conversion. Okay, so we start with our molecules, we cancel molecules, and we find moles, and then we take our mass and divide by the moles. That's perfectly good. Totally good way to do it. 2 steps, 2 different lines. You can do it all in one line if you want to. Okay, so option B is to write your molar mass to start out with grams on the top and molecules on the bottom. So you really have grams per molecule here, yes? And then you can convert your molecules by canceling them this way, yes, per mole. Whichever method you prefer is fine, yes? Okay. Is there anything else we need to know here? Oh, this is a favorite question that always shows up on quizzes and tests. Okay? Now, your question won't be about oleic acid, but the question will read very similar. Oleic acid is it'll be like some random molecule that you've never heard of. Okay? Or it'll be like, I don't know, caffeine is a molecule, blah, 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 blah. And you don't know the formula of caffeine, right? You don't know the formula of oleic acid, but you do know that a molecule of oleic acid has a mass of 4.692 times 10 to the negative 22 grams. Does that seem like an appropriate number of grams for one molecule?
Yeah.
Yeah, it's really small, right? One molecule is going to be very, very small mass. The key to this question is realizing that you have a word here, that is actually a number. What number is that? 1. Okay, so people will often get to this question and they'll be like, I don't have a number to start with. I don't know what to start with. If it says a molecule, it's going to say it's 1 molecule. That's what you're starting with. So you could convert 1 molecule, cancel your molecules, find the moles, take your mass, divide by your moles, or you can do it all in one line. You can say, I have the grams I was given over 1 molecule. Cancel your molecules and find your moles. And you want moles to be on the bottom, so moles does end up on the bottom. Okay? Now, in my regular chem class, I do really kind things. Like I'll put a molecule and I'll like bold it and underline it. You're not getting a bold and underline. You're in enriched chemistry. You need to remember that a molecule is 1 molecule. Okay? That's not on this Thursday's quiz. This will be on a quiz next week. Okay? Okay. You can abbreviate molar mass like this. I think we already said that. You can actually use GMM, which stands for gram molar mass, or you can just write MM. Okay? But the GMM has sort of fallen into disuse. It's really old-fashioned, so I don't know if anyone would know what you're talking about. Anyway, there's a bunch of exercises here, which we are not going to look at right now because we are going to keep moving because this is Chem 11 Enriched, and we never stop. Okay. Sorry. Page 79. What do you think molar volume means? You know what molar mass is. Sorry? Yeah, how much volume 1 mole of the substance takes up. Yes, molar mass is the mass of 1 mole. Molar volume is the volume of 1 mole. So molar mass was grams over moles. Molar volume is going to be liters over moles or milliliters per mole. Okay, it could be kiloliters per mole, whatever. Anyway, that's what it is. Okay, volume over moles.
It can also be centimeters squared over mole.
Yeah, it could be. Yeah, it could be centimeters cubed. Okay. Now, we have to talk a little bit about different substances because different substances behave differently. So if I have, this pen, which is a solid, and right now it's at room temperature, if it was all of a sudden 0 degrees, would its volume be any different? Not measurably, okay? Because all the molecules are close packed already. Yes? You might get a little bit of expansion, a little bit of contraction, but at the temperatures we're using, like say in a lab like this, you're not going to get a noticeable difference. Okay? Gases are a different story because if you heat a gas, what happens to the particles? They don't just jiggle faster. What do? Choo, choo, like they're moving way, way faster, which means they spread out and take up more space. Okay, so now at standard temperature and pressure, which is known as STP, the volume of 1 mole of a gas is 22.4 liters. And how are you going to remember that? It's as easy to remember as 2 plus 2 equals 4. So if you're like, is it 24.2? You're like, no, 2 plus 4 does not equal 2, right? It's 2 plus 2 equals 4, so 22.4. And guess what we have? What's that? Every gas at standard temperature and pressure takes up 22.4 liters of space. And I'm going to go get a box that is that volume, if we have it. There it is. So here, this box contains 1 mole of gas. Okay, we're not at standard temperature, so maybe it contains a tiny bit less gas, but we're just going to say, like, this is close enough. Okay? So the molar volume of a gas, and we're going to put a big star here, and we're going to say any gas. Doesn't matter what gas, CO2, CH4, NO2, SO2, N2O4, does not matter. 1 mole of gas takes up the same amount of space.
Don't they have different densities?
Huh? They will have different densities, but they take up the same amount of space. So if you have 1 mole of hydrogen gas, H2, has a molar mass of 2, yes? And there's 1 mole in here. The gas in here will have a mass of 2 grams. If you have methane, which you were just using to burn the flame, CH4, you have 12 plus 4 is 16. There will be 1 mole of methane gas in this container, and it will weigh 16 grams.
Oh.
Yes? So the masses are the same, but are different, but the number of particles is the same. Okay? Now, what is standard temperature and pressure? Standard temperature and pressure is 0 degrees Celsius and 1 atmosphere of pressure. ATM stands for atmosphere. And guess what this number is now going to be? 22.4 liters per mole. We now have another conversion factor. Oh, let's go look at our mole sheet again, your yellow sheet. And you remember we had gotten to density, we've got volume of A, which could be a solid or a liquid or a gas. But if we have a gas at STP, at standard temperature and pressure, we are going to use the molar volume. And what is the molar volume? 22.4 liters of gas per mole. So now I could say you have 40 milliliters of CO2 gas. Please tell me how many CO2 molecules that is. You know what I mean? I could give you the volume of a gas. You could convert it to moles of a gas. Then you could convert it to the number of molecules. Or I could say, how much space does 3.6 times 10 to the 24 molecules of SO2 gas take up at STP? Okay, and you would say, oh, I got the molecules. I can find the moles. And from there, I can find the volume of the gas. Is good? Yes. Okay. Now I know it's a lot all at once, but you'll get so used to it, you'll be like, oh, it's all easy now. Okay? It will get that way. Takes a while to get used to, but it's not bad once you've done it for a while. All right. 5 points. There we are. Yes. Molar volume and molarity are not the same thing. It's a good question. Molarity is for solutions. Okay? It is moles per 1 liter. Okay, so we have some number of solute moles per 1 liter. Per liter of solution. Now, molar volume is for gases. It's actually for all substances, but all solids, liquids, and gases. But for gases, it is always the same. What does STP stand for? Tell your partner. Standard what? Temperature and pressure. Do you remember what standard temperature and pressure is? What's standard temperature? Standard temperature is 0 degrees Celsius. What's standard pressure? 1 atmosphere. How do we abbreviate atmosphere? ATM. Okay. So molar volume, you can have a molar volume for any substance, right? You could have a mole of gold and you can say, how much space does this gold take up? You can have a mole of water and you can say, how much space does this water take up? Okay. But these are for pure substances, not for mixtures. Okay. I should put that in here. Pure substances. All solids, liquids, and gases that are pure substances, but for gases, it is always the same. And what is the molar volume?
Substance.
22.4 liters per, woo, why does that L look so weird? Liters per mole. So let's take per 1 mole. Now let's take a look at molarity, which is some number of moles per liter, and that's variable depending on how much solute you add. Yes? Molar volume is set for a substance, right? If you have gold, it's always going to be the same because a certain 1 mole of gold is always going to take up the same amount of space. Now, the only thing that's going to change that for gases is there's 2 things actually, pressure and temperature. So if we change the pressure, the molar volume will change. If we change the temperature, the molar volume will change. If we change the temperature and pressure for a liquid or a solid, you'll get minute changes, not enough for us to worry about at this level of chemistry. Okay, so you can assume that like for solids and liquids, essentially their molar volume is just stable and consistent. Okay, but for gases, they have significant expansion and contraction. Is good? Okay, we are almost out of time. So I'm going to wrap it up there. And I'm going to actually, because we've got 5 minutes left, what I'm going to do is if you have done your pre-lab assignment with your pictures, you're going to come up here and get me to sign it for you. And that's going to be part of your grade for your lab. Okay? And your homework is to do 5.4C. Homework, 5.4C. Molar mass. Hello. Excellent.
Huh? What do you mean? I did like the exact same thing you did.
So beautiful. Look at you, artist.
My God.
Nice.
Thank you.
Excellent. So you'll just tear that out and attach it to your lab when you're ready. Good stuff. Beautiful. Go. Excellent. Thank you very much. You guys are so much better than my last bunch. They didn't believe me. That's so cute.
Yeah.
There you go.
I was making my
Yeah, this is Ryan. I did this well in the DC.
Hello. Excellent. So good. Excellent.
Just beautiful.
They're gorgeous.
Thank you.
They're actually way better than mine because I can see a wrist and fingers and thumb.
Is this one?
Yes. Okay, that's kind of sad. I need you to redo that and do it on paper.
Okay.
Okay? Yeah. Hello. Excellent. That's okay. Very nice. Thank you. That's okay. That's okay. Hi.
I have 2 questions.
Yes.
Maybe a problem I give it to you tomorrow.
That's okay.
Okay. Just curious, does like atmospheric pressure change? Let's say if we're in like sea level, let's say Colorado.
Mm-hmm.
Nice.
Yes. Yes, definitely. So at sea level where we are, we're at 1 atmosphere.
Oh,
Okay. But in Colorado, it's going to be less. Yeah. And we'll talk more about like pressures and gases in unit 13. Yay.
all right. Thank you.
Okay. Hi.
I didn't have any pictures
Okay.
because I just did it in the morning. But
Okay.
I just
Yeah, that's right, because you were not here. So I'm going to say that's okay. If you want to draw some pictures for tomorrow, just to solidify it for yourself. Otherwise, no, you're fine. Okay. Hello. Thank you very much. There you go. Hi. Thank you very much. Thank you.
Hi. Oh no, it's okay. It took you one time. I get these now.
Oh, hey, look, we're matching.
Cool. So uncomfortable.
Yeah? I got used to it really quickly though. So maybe,
How long have you been wearing them?
like a week.
A week?
A week and a half. We don't actually, I just switched to my second one.
Oh,
Yeah.
so we started almost at the same time.
Almost at the same time, yeah.
Yeah.
My teeth are actually, like, they're straight enough, but, because I'm old now. These teeth are rubbing on these teeth.
Oh, I have the same thing.
And so they're wearing. And I'm like, well, why don't I deal with it? Well, I still have like dental benefits from being a teacher, right? So
That's
yeah,
Yeah.
right? I do before I retire, so I don't have to
Oh,
leave.
that's why
Hi. Yeah, for sure.
I just wanted to ask a question about the next one. I don't know how much I've actually missed.
So basically what you missed is you missed lighting a Bunsen burner.
I know how to do that.
Yeah. And you missed like a little bit of a lecture about like things in the lab. But you got the computers here for all of that.
Yeah.
Yes. And you know all about like
Fire safety.
your partner goes to this horrible thing. Okay, good. So that's all we really needed to know. And what else? I just kind of showed stuff, but it's all in the procedure anyway. It's just kind of like, you know, because it's the first lab, I just want to the lab, the rest is we're gonna talk about it. Yeah, you've got a partner who's here.
I'm so happy everything is moved like to later. So
Yeah.
Yes, for that today.
Yeah, no, it worked out actually quite well. I was like, hang on, we need to do Bunsen burner lighting, we need to do fire safety, we need to fold filter paper. Here, I'll show you how to fold the filter paper. Do you know how to fold filter paper? Fold it like this. Okay, start the easy part. And then fold it in half again. And the only part that's tricky is opening it up so you get a hole. You do not open it up with 2 layers and 2 layers. You open it up with 1 layer and 3 layers coming. Oh, get it on. Okay. And then you use like a little bit of a spray bottle on it, and it'll make it stick to the funnel.
I think we did something like that before.
Probably, yeah. So you didn't necessarily. It's actually a good class you have missed. A lot.
I'm so happy.
Yeah.
I have so many classes that I have to come to class.
Yeah.
Yes.
Yeah. So chemistry, no. Don't worry about it.
That's good.
Yeah.
Thank you so much.
No problem.
Have a good day.
You too.